This is Mr. Baker, and we're looking at the Quadratics EoC prep worksheet. Make sure you check here if you're thinking that you don't remember a formula. Most of the formulas we're going to need on this worksheet are here: vertex form, standard form, factored form, quadratic formula. So let's get going. All right, this first problem, select all expressions equivalent to 12x squared minus 27. Well, we've got 5 things to choose from. There may be more than one that's correct. Really, this should be a factoring problem, but that's probably not the best way to do an equivalent problem. When you're looking for equivalent stuff, what you really want to do is know that for every value of x in the original problem, the answers that are equivalent are going to give you the same value. So no matter what I plug in for x in the problem, I should be able to plug it into these answers and get the same thing. Now, not every number to plug in is created equal. You don't want to plug in 0. You get too many false positives out of that. Same with 1, same with 2. The smallest number I would plug in is 3, but 7 is my favorite number to plug in. So let's try that. Let's plug in 7 to that 12x squared minus 27. So 12 times 7 squared. 7 squared is 49. Times 12 and then minus 27. Probably just shove that in our calculator and it's going to give us 561. So let's do the same thing, plugging in 7 to all of these different expressions. And they're going to give us a few different numbers, really just 2 different values. Everything that's equal to 561, those are going to be equivalent to what we started with. The ones that equal 363 obviously are not equivalent. Now, when I said false positives, sometimes you can plug in a number and accidentally get the same value out. That's why I like 7. It's a prime number. It's not going to be as likely to accidentally give me the same number, and it's why I like to avoid the numbers we talked about earlier. There are certainly other ways to get these 3 answers. If you left one short on the end of course test, that's going to count it wrong. So plugging something in like this is a good way to make sure we get all of them. Next up is a pretty standard problem. We're going to write this in vertex form. Vertex form is, of course, f of x equals a times x minus h squared plus k. That could be y instead of f of x. Same stuff. So we've got to figure out what a equals, what h equals, and what k equals. Now, a lot of people want to plug in all 3 of these numbers from the standard form. Please, please, please don't do that. That's not right. But we can steal one of them, and that's that -3. The a value doesn't change when we switch forms of an equation in quadratics. So if that's a -3 for a here, it's going to be a -3 for a in our vertex form. The h, on the other hand, and you can find this formula on the reminder section. It won't be given to you for the end of course. But you can look it up there since we're just reviewing. That comes from the fraction -b over 2a. And we've got a, b, and c in our standard form up here. So we want -b over 2a. That's going to be -12 over 2 times -3. Simplify that out. It's going to be +2. So that's going to be our h value. Now when we plug that in, right there in the parentheses with x, we got to remember what x's do. X's lie. It's going to give us a different sign, so we want to make sure that's a -2 there. Well, I've got my a, I've got my h. How do I get my k? We're going to plug in this 2 we just found into the original equation. That's what the equation's job is. Once you know an x value, it finds a y value to go with it. Since k is the y value of the vertex, we just need to find the y value that goes with 2. So plug that into the equation, and that's going to spit out 4. So my k value is 4. Y's tell the truth, so that's going to be a +4. So -3 x minus 2 squared plus 4. Now that is one way to do this problem, but it is not the only way to do this problem. Especially if you're a graphing calculator person, maybe you just wanted to graph the equation. So maybe you get your graphing calculator and you hit y equals, type in the equation on that first line, and then hit graph to take a look at it. There's our graph. Now that's kind of hard to write an equation from, but all we really need is that vertex. If we can find the vertex, we should be able to write the equation from that. Again, it's hard to look at the calculator and see. You could try trace, but I recommend hitting second and then trace. That's going to give you that calc menu. We've used that before. And the way that that parabola was shaped, it was a sad parabola. We get a maximum. So our vertex is actually a maximum. So once you're in that calculate menu, if you tell it 4, you've got to do a few things. It asks for a minimum and a maximum. Just for the left bound and the right bound is what it asks for. Left bound, type something way too small to be the answer, like 0. 0, clearly it's some positive x value, so maybe you'll type in 0. Something way too big to be the answer for your right bound, maybe 10. And it asks you to guess. You don't have to guess. And at the end, it's going to tell us an x value and a y value. Now, your x value especially might be just a little bit off. This might say 1.9999984, or it might say 2.000013. If it's that close, just go ahead and round it. It's going to be 2.4. That's just a limitation of the calculator. Not quite rounding, or not quite being as accurate, so it rounds it as best it can, and it carries a lot of decimal places. But if I've got 2.4, that's my vertex now. We just found that. We can plug those numbers straight in for h and k in the equation. Once we know those numbers, we know x is lie, so since that's a positive 2, we want it to say minus 2. Y is tell the truth, plus 4. And where's my a come from? I still get it the same place I always did. I'm going to steal it from the equation. So there's our 3. We're just going to steal that, plug that in right there. Exact same equation, 2 different ways to find it. We can graph it and write the equation from the graph, or we can use the numbers, negative b over 2a, and then plug in to find the k. I don't care which way you do it. Just make sure you can get through that kind of problem. We worked a ton with that at the beginning of the year. Number 3, we've got 3 different functions here. F of x gives us an equation, g of x gives us a table, h of x gives us a graph. And we're supposed to figure out which of these statements is true based on those things. And they're all talking about the same stuff, aren't they? They're all talking about y-intercepts. So we definitely want to find y-intercepts. Probably the easiest place to start is with h. Y-intercept is going to be where it crosses the y-axis. It's right there. It's at 1. Easy enough to spot. Probably the second easiest is going to be the g of x. Now, we don't have a graph to look at, but we do know that every point on the y-axis has the same x-coordinate. That x-coordinate is 0. So if you look at the list of x-coordinates, here's 0. The y-coordinate that goes with it, that's going to be my y-intercept. So negative 4 is my y-intercept for g. And that same knowledge can give us f of x's y-intercept. Knowing that x is 0, we just plug in 0 for x. Negative 2 times 0 plus 3 times 0 minus 5. Simplify that. That's going to give us positive 30. So we've got the y-intercept for each of those. 30 for f, negative 4 for g, 1 for h. And now we can look at these statements and figure out which one's true. Now, starting at the bottom, looking at d down here, 2 of these functions have the same y-intercept. We can tell very easily that's not the case, so that one's out. So maybe we'll start at a. Some people like to go backwards through these. It doesn't really matter. You're going to want to look at all of them anyway, because if you feel like 2 are correct, then you may have to go back and analyze some more. So the y-intercept of f of x is 10 units below g of x. Well, let's just go ahead and f of x is 30, g of x is negative 4. Is 30 10 units below negative 4? No, that one's not right. Try it with b. Negative 4 is 5 units above the y-intercept of h, which is 1. Now, it sounds pretty convincing, but watch for the words. Negative 4 is not above 1. 1 is above negative 4 by 5 units, so it was close, but not quite. Process of elimination tells us it's going to be C, but if we try to rule that one out too, maybe we did something wrong. So let's read it. The y-intercept for H is 29 units below the y-intercept for F. So 1 is 29 units below 30. That sounds right. That's the answer we were looking for. All right, we see on the left side, this is a no calculator problem. So don't reach for that calculator. You really shouldn't have to. This should be actually a pretty easy problem. And remember, there is a non-calculator section to the end of course test. Now, it gives us a standard form of the polynomial, but we don't even need that because it then says it can be written as 4x plus 3 times x minus 6, which is the factored form. And it asks, what x values does the graph cross the x-axis? Well, factored form is really good at telling us x-intercepts. So we're going to use the factored form. And the main thing we want to think about is that x's lie. Now, it's not quite that easy. It's not just the signs we're going to be dealing with, but it's pretty close to being that easy. So let's look here. Let's start maybe with the x minus 6. That one's going to be easier. That is a direct application of the advice that x's lie. If x minus 6 equals 0, which is why the x's lie, we just get x by itself. Add 6 to both sides, x equals 6. We've got our answer right there. How about the 4x plus 3? A lot of people are going to be tempted to go with negative 3, which isn't even one of the answers. It would be much meaner to put that as one of the answers, but that's not right because we still want to get that whole set of parentheses to equal 0, and that's not a one-step solution, that's a two-step solution. We're going to have to subtract 3 from both sides, and we're going to have to divide both sides by 4 to finish getting x by itself. That's going to give us negative 3/4. Negative 3/4 is equivalent to negative 0.75, so that is the answer we were looking for there. We know this stuff about factored form. Again, it's been a while. Everything on this worksheet's been a while. That's why we're reviewing it. This should be one of the easier ones for us because once it's in factored form, it's really good at telling us what the x-intercepts are. Okay, this problem asks us to find the solutions of the equation being 4x squared minus 3x plus 5 equals 0. And that x squared, not to mention the title of this review sheet, tells us this is going to be a quadratic equation, which means we have 3 ways to solve them. We learned to solve them by factoring. That's P and Q, set each chunk equal to 0. That's not going to work on this problem. One of the hints that this might not work is it talks about radical form, writing it in simplest radical form, and factoring is never going to give us radicals. Sometimes we can take the square root of both sides, but in that case, there'll only be one x and it will be squared, maybe in parentheses, maybe not, but this has an x squared and a plain x, so that's not going to work either. The one technique that works on absolutely every quadratic equation is the quadratic formula. So we're going to go ahead and use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So a is 4, b is negative 3, c is 5, all from the original equation. Do make sure you're equal to 0. This one is. If it wasn't, we'd have to add or subtract to get 0 over there. That gives us a, b, and c, and we can plug all of those in where they belong. Make sure when you square that negative 3, you get a positive. Now, if you tried to shove all of this into your calculator at once, it's going to give you an error, and this is why. When we simplify everything inside that square root, you get that negative, and calculators don't like that. We know how to simplify a radical with a negative in it. It's not as painful as it sounds. We're just going to pull an I out. So 3 plus or minus I squared root of 71 all over 8. Normally this would be where we simplify our radical, but 71's prime, and that's not going to simplify, which means this is as simple as it's going to get. We've got our answer, 3 plus or minus I squared root of 71 all over 8, but we have two boxes, and the directions tell us if there is only one solution, leave the second box blank. So if I write this in the first box, there's nothing left to write in the second box, and that tells me there's only one solution. But there are two solutions. The plus or minus gives us two solutions. One from the plus, one from the minus. So we're going to have to write them separate, once with a plus, once with a minus. So there's the one with the plus, there's the one with the minus, and we've got our two solutions in our two boxes. Remember, quadratic formula always works, and this is one of those things that I will definitely expect to see, probably in this same format, on the end of course test. Next up is a graphing problem. Now, it doesn't actually want us to make the whole graph. It tells us to use the coordinate plane to graph the following points. So just a few points to graph: the x-intercepts, the y-intercepts, and the maximum or minimum. And it says the coordinates should be accurate to the nearest half unit, which means you don't have to worry about the difference between, 0.1 and 0.2. Those aren't going to be a big deal. But it does tell me that they're probably not all going to be really nice points. So let's start, though, with the y-intercept. That one's actually going to be the easiest because we're in standard form. And standard form is good at telling us y-intercepts because that's what the last number tells us, is the y-intercept. So our y-intercept here is going to be -1. So that was easy. The other ones are going to be a little harder. Let's go to x-intercepts. That's where we cross the x-axis, sometimes called roots, sometimes called zeros, sometimes called solutions. And I say that one because that's probably the best technique we've got for this, is to plug it into the quadratic formula just like we were solving it. So there's the quadratic formula, and we're going to plug in our a, b, and c and simplify. And we can plug all this into the calculator this time if we want to. I usually simplify stuff by hand for a while, but since we're going to want to graph it, we probably want a decimal this time. So let's go ahead and get one. Once with the plus, once with the minus. So the two answers we get are 0.18 and 1.8. Now, those aren't easy things to graph, but 0.18 is going to be pretty close to 0. 1.8 is going to be pretty close to 2. They only have to be accurate within the nearest half unit. So as long as they're kind of close, we're in good shape. Now, for finding the maximum or minimum, that's just the vertex. Those are just specific words. This one, we can already kind of tell what direction this is going to be going in, not to mention the fact that our a is negative, which means it's going to be a sad parabola. So we're going to have a maximum somewhere, I don't know, probably up here somewhere. But we can find that just like when we were changing things into vertex form. We can use negative b over 2a to find the x coordinate of that vertex. So that's going to be -6 over 2 times -3. That's going to give us 1. So my x coordinate is 1. But 1 what? Not 1, 0. Probably not 1, 1. Maybe 1, 2, 1, 3, something like that. Maybe somewhere in between there. So how do I know for sure? Plug it in. To find the k, we just plug in that 1 we found in for x. So -3 times 1 squared plus 6 times 1 minus 1. And that's going to give us 2. That's my y coordinate. So 1, 2, that's going to be the ordered pair for my vertex. Now we could draw our parabola through that if we wanted to, but there will be some graphing problems that don't want you, or could be some graphing problems on the end of course that don't want you to draw the whole picture, just want a few key points like this. And it won't give you an option to draw the whole picture. The other thing we could have done, of course, is we could have graphed this on the calculator. That's a whole different set of challenges for getting this accurate. Maybe use trace will get us close enough to be within that half unit range that we're supposed to have. Maybe we do things like second calc and find the x-intercepts, which are zeros on that menu. Find the vertex. All right, this last one's an interesting one. We're supposed to write equation for a parabola based on some information, but it doesn't tell us what form we need to use. We can use any form. So we get a few choices. Probably the best choice, because it gives us x-intercepts, is going to be to go with a factored form equation, because we know that x's lie, and factored form is one of the best applications of that, because it's got two sets of parentheses which each come from the x-intercepts. So we know the x-intercepts are 4 and -2. Well, that means that my two parentheses should be able to be x minus 4 and x plus 2. X's lie, we just need to change those signs. But that doesn't give me my a value. So what is a? Is it this 12 right here? Well, no, it's not, but that's going to help me find what my a value is. Since 12 is the maximum value, that means it's the y value of the highest point on the graph, which is going to be the vertex. So we need one more point to make this work, and the vertex is going to be that point. 12 is the y value. What's the x value? Well, in a parabola, the vertex is always halfway in between our x-intercepts. So we've got 4 and -2. Halfway in between those, we can add them and divide by 2. It's going to give us 1. That's going to be the x-coordinate. So remembering that that vertex is halfway between the x-intercepts can be helpful. If we know the x-intercepts, we can find the x-coordinate of the vertex. So how does this help me find a? Well, I know that x, when x is 1, y is going to be 12. That's what knowing an ordered pair from the graph is going to be helpful with. So we can plug that in. And that's going to be -3 times +3 times a is going to be 12. So -9a is equal to 12. Get a by itself. We'll divide by -9. That'll simplify a little bit, give me -4/3. -4/3 is my a value. So that's going to be y equals -4/3 times x minus 4 times x plus 12. That is our factored form version, but we didn't have to go factored form. We could have gone with standard form, which is really hard to write an equation for, or we could have gone vertex form. So, or maybe we'd go vertex form. We've got a lot of that information and we find it the same way. We can use the x-intercepts to find the x-coordinate of the vertex, and then we've got the y-coordinate was given to us in the original problem. So this time we can go vertex form. Y equals a times x minus h squared plus k, because if we did the work to find the vertex, which we had to do anyway in the factored form, we can write the vertex form of the equation. H is going to be the x-coordinate of the vertex, k is going to be the y-coordinate of the vertex, x is lie, y is tell the truth. So x minus 1 squared plus 12, but we still need to find a. A is still going to be the same thing. We already know what it's going to be because we've worked it out once already. But the whole same idea is going to hold. We need to get one more point on the graph. We've already used the vertex, so maybe we could use the y-intercept, but I don't know the y-intercept. I do know some x-intercepts. So let's use the x-intercept. And I could use either one of these two x-intercepts. I don't need both of them. It's not 4 and -2. Every x-intercept has 0 for its y value. So 4 is the x-coordinate, 0 is the y-coordinate. We could have used -2 instead if we wanted to. And now we plug those in for x and y. And just like we did with the factored form, we just get that a by itself. A little bit of work. It's 3 squared. That's going to be a times 9 equals 12. We subtract the 12 from both sides. Divide by 9. Simplifies the exact same way, negative 4/3. So now the equation is y equals negative 4/3 x minus 1 squared plus 12. It said any form, so we can do that. And if we needed standard form, we could have written either one of these forms and then multiplied everything out to make it standard form. So that could have worked too, but if it lets us do any form, then I see no reason to change it once we have it written. So that's our 7 problems, our review problems for quadratics. This is going to be one of the biggest parts of the end of course test. So if you're struggling with some of this stuff, maybe go back to when we did quadratics back in August or September on my calendar, on my website, and maybe watch a couple of those videos as refreshers if this wasn't enough. But I hope this was helpful. I hope you feel a little more ready. I hope you've got this done so you can get that 100 on your quiz grade for this review sheet. And I'll see you in class or see you in the next video.